Hello friends, how are you? In the last lecture, we have discussed horizontal acceleration and example based on horizontal acceleration. Today, we will discuss motion in vertical direction. So whenever we consider motion in vertical direction, so again we can categorize this into three groups. Okay, so one is free fall, motion in downward direction with initial velocity, motion in upward direction with initial velocity. Okay, so now this motion is accelerated motion or not? Yes, motion is accelerated motion. Why? Because when we drop the object, okay, initial velocity 0, then velocity increases with time. It means motion is accelerated motion. Then what is acceleration? So in vertical direction, acceleration is, so it's a free fall. So acceleration is gravitational acceleration. Okay, so now you know what is gravitational acceleration. Okay, so motion under the gravity. So acceleration is gravitational acceleration. So which is the force acting on the object, that is gravitational force. So acceleration is called gravitational acceleration. Okay. So in absence of external resistance, okay, we are assuming the acceleration of the object, so that is g. Okay, so here we are assuming one dimensional motion, okay, under gravity, in which air resistance and small changes in the acceleration with height are neglected. Okay, so it means we are simplifying the cases. Okay, so now consider first case. So motion in downward direction. So there are two cases: motion with initial velocity 0 and motion with initial velocity. So first consider motion with initial velocity 0. So body dropped from some height. So initial velocity v is equal to 0. Okay. So now, so various relations already we are using. So same relation we can use, just introduce, instead of a use g, and instead of u, okay, u is equal to 0. So replace u by 0. Okay, so first equation, v is equal to u plus gt. So here we are considering u 0 and acceleration g, so that is positive. It means here we are considering motion. Okay, along the motion, direction is positive. So motion and direction of g both are same. So it means we are considering both are positive. So next equation, final velocity v is equal to gt. Okay. So final velocity v square is equal to, so s is equal to ut plus 1 half gt square, u0, so h is equal to 1 half gt square, v square is equal to 2gh. Okay, and distance traveled in nth second. So again u0 g by 2 2n minus 1. So h and g by 2 2n minus 1. So this equation you can recall very easily. But most of the time in example we need shortcut because we want to solve the example quickly. Okay. So now suppose for free fall, so time of flight, suppose you want to find time, so time t is equal to, then you can say u by g. So one equation that is v by g, or initial velocity u by g, and second, if height is given, then 2h by g, the under root 2h by g. So if initial velocity is given, directly you can find time u by g. If height is given, directly you can find time t under root 2h by g. Okay, if height is given and if you want to find final velocity, so okay, v is equal to under root 2gh. So remember this equation, v is equal to under root 2gh. Okay, so shortcut you have to remember. And suppose final velocity is given, you want to find height h, so h is equal to v square by 2g. So you have to remember all these shortcuts. Okay, and next you have to draw the graph. So graph of distance versus time, velocity versus time, and acceleration versus time. So distance h, so h is equal to 1 half gt square. So h is equal to 1 half gt square. It means relation is like y is equal to x square. So y is equal to kx square, then it's a parabola. It means equation ht. So ht graph should be parabola. Okay, velocity time graph. So v is equal to gt. So y is equal to mx. So this graph should be straight line. Okay, so next topic, so that is draw the graph. So graph of distance, velocity and acceleration with respect to time. So for free fall, so it's a parabola. So h is equal to 1 half gt square. Velocity, so directly proportional. Okay, so velocity increases, y is equal to mx. And acceleration, so acceleration is constant, so that is straight. Acceleration is constant, so that is straight line. So now second case, we throw the object with initial velocity u. Okay, so now here we cannot consider u is equal to 0. So now normal, replace a by g. So same equation of motion, v is equal to u plus gt, v square is equal to u square plus 2gh, h is equal to ut plus 1 half gt square, and h and u plus g by 2, 2n minus 1. Here what we are assuming? We are assuming motion of the object, so that is positive, this direction is positive, and g is also positive. Okay, now consider third case. Okay, object is moving in upward direction. So always we consider positive direction, so that is direction of motion. Okay, so upward direction positive. So what should be the g? So value of g should be negative. Value of g should be negative. So now replace v is equal to u minus gt, hn is equal to u minus g by 2, 2n minus 1, v square is equal to u square minus 2gh, h is equal to ut minus 1 half gt square. Okay, so you can use this equation for third case. Okay, so here we are considering the direction of motion, that is positive, and everything opposite to it, it should be negative. So value of g is negative. So now consider third case. So projected vertically upward, so acceleration is negative. Okay, so already we have used all the equations. Now again shortcut, because in most of the case some situation is given. So now suppose when in upward motion the final velocity, so that is 0. So final velocity is 0. If you know the initial velocity u, so what should be the height h? So you can derive the equation. So for maximum velocity v is equal to 0. So v square is equal to u square minus 2gh. So h is equal to u square by 2g. What should be the final time? So final v is equal to u minus gt. So u is equal to gt, and time t is equal to u by g. H is equal to 1 half gt square, and v square is equal to 2gh. So from all this equation we can find out shortcut. So t is equal to u by g under root 2h by g. V is equal to under root 2gh, and t already it is given. Okay, so h is equal to u square by 2g. Okay, so again you can recall or remember this equation. So shortcuts are important because directly or quickly we can solve the example. Okay, so now again graph. So for graph, okay, so for graph, and h is equal to, so not for v, so h is equal to ut minus 1 half gt square. It means y, so that is asymmetric parabola. So graph is asymmetric parabola. Okay, so with increase in time, distance increases. At one moment distance is maximum. So for maximum distance we have derived the formula u square by 2g. And what should be the time? So time already we have given, u by g. Okay, so time of flight during upward motion and time of flight during downward motion, both should be same. Okay, so at this point time should be twice u by g. So time should be twice u by g. So this is st graph. So now vt graph. So with increase in height, velocity decreases. Okay, in downward direction velocity increases, but upward direction positive, downward direction negative. So velocity increases but in negative direction. Okay, so now you can see first velocity decreases, at this point velocity 0. Okay, now again velocity increases but in negative direction. So time of flight at height, maximum height u by g, again at the bottom, so that is twice u by g. Okay, and acceleration. So acceleration, so that is acceleration is constant, but negative acceleration, so that is minus g. Okay, so just wait a moment. Next, okay, so suppose if we drop a object, okay, suppose we drop two objects, one is heavier and second one is light. Okay, so both will reach the bottom at the same time or at the different time. Okay, so in our equation h is equal to 1 half gt square. It means time is independent of mass. Okay, it means both will reach at the same time. But the condition is here we are assuming external resistance is 0. It means in the environment it should be perfect vacuum environment. Okay, so we will see the video of this experiment.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out the 30 tons of air in this chamber until there are about 2 grams left. And it's kind of got an eccentric construction, which is part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems, and that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding and part an external pressure vessel, so that this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest.
Presence of air resistance.
Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So, in order to see the true nature of gravity, we have to remove the air. It takes 3 hours to pump out the 800,000 cubic feet of air from the chamber.
Okay, we dropped 2 millitorr in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCV 30-1, pressure set point at 240 psi. We are go for drop.
10, 9, 8, 7, 6, 5, 4. Cameras on. 2, 1. Release.
Are moving simultaneously.
Look at that.
They came down exactly the same. Wow.
Look.
Watch right there. Look at how they hit right there.
Exactly.
You're back on the side.
Exactly the same.
Feathers don't move, nothing.
Look at that. That's just brilliant. Isaac Newton would say that the ball and the feather fall because there's a force.
Okay, so this is just for information. Okay, so now let us solve few examples. If a body is thrown up with velocity 15 meter per second, so thrown up means third case u 15, then maximum height attained by the body. So now directly recall the equation h is equal to u square by 2g. No need to use the formula, directly you can use this one. Okay, so u square, so 225 divided by 2 into g, so that is 10, so 11.25. Okay, So otherwise what we have to write? So first v square is equal to u square minus 2gh, v is equal to 0, then you will get h. So directly now you can use the formula. Okay. A body falls from the rest, u0, falls from the rest, first case, in gravitational field of the earth, it means g. The distance traveled in fifth second, distance traveled in fifth second, so hn, u0, so say g by 2, 2n minus 1, g is 10 by 2, 2, fifth second, 2 minus 1, so 10 minus 1, 9, 9 into 5, 45 meter. So distance traveled in fifth second, that is 45 meters. So in 1 second, okay, so that is 45. 45 meter is very long distance. A ball is thrown vertically upward with speed u at a distance covered during the last t second of its ascent. Suppose ball is thrown in upward direction. Okay, so after t second, okay, ball will reach at the maximum position. So total time taken by ball to reach the top position, so that is t second. I can say suppose 20 seconds, so that is t is equal to 20. So what is the distance covered during the last t second? It means distance covered in last second. It means last second means 20th second. Distance covered in last second. So that is t. So find out distance covered in last second h. So h is equal to, okay, g by 2, 2n minus 1, not given option. Okay, h is equal to ut minus 1 half gt square. So for that, what is u? So u we don't know. So here there is a problem. Okay, so now here we can use the equation h is equal to ut minus 1 half gt square, because upward motion, so that is u. But now here u means which u we have to consider? So here we have to consider u means velocity at height, at this height. Okay, so I can say that is u at time t. So instead of u I have to write here t. But initial velocity u is given. It means at the bottom initial velocity u. It means find out ut. Find out ut. So find out ut. So find out ut. So how can we find ut? So if we know initial velocity, so final velocity v. So I can write ut is equal to u minus gt. Or I can say to reach this moment, it means to reach at this height, I can say time required, so that is called t1. Okay, so instead of t I can write t. So to reach to this height, time required is t1. So u minus g t1. So now t1 is not given. So find out t1. Okay, so how can you find out t1? So find out t1. So suppose the total time t. So total time t is equal to, so I can write initial velocity u is given, g is given. So total time u by g minus time in last second. So last second, so that is t second. So u by g minus t. So that is time t1. So now I can replace u minus g, u by g minus t. So replace g, so g cancel, multiply it by g, u cancel, so finally you will get gt. So u at time t, so that is gt. So this is gt. So replace u by gt, so gt into t minus 1 half gt square. So gt square minus 1 half gt square, so answer is 1 half gt square. So if we are in hurry, we can write ut minus 1 half gt square, but actual answer is 1 half gt square. But normally you will not find such type of example in the NEET, because here more steps are required. Okay, generally the question should be in a position, or answer you should get the answer within 1 or 1.5 minutes. So here it is difficult. Okay, but concepts are important. Okay, so here whenever so situation is there, you can use this concept. Okay, so in the exam you can find simple solution. Okay, so here you can use the formula ut minus 1 half gt square. You don't know u, so find out u, so v minus gt. Okay, and then t1 is not given, find out total time minus this time. Okay, next example. A man throws ball with same speed vertically upward, one after the other at an interval of 2 seconds. So suppose a man throws ball. So first ball after 2 seconds, second ball after 2 seconds, third ball at an interval of 2 seconds. So what should be the speed of throw? What should be the speed of throw so that more than 2 balls are in the sky at any time? Okay, so what should be the initial speed? So more than 2 balls should be in the sky. So now think about the situation. Suppose when we throw the first ball, so first ball will reach to the maximum position. Okay, at the same time throw second ball. So when second ball reach to the maximum position, the first ball will reach at the bottom. So second ball will reach to the maximum position, the first will reach to the bottom, and the man will throw the third ball. So now in this situation, all the balls are in sky. All the balls are in sky. Okay. So what should be the condition? So how to start the example? So now think about the first ball. So first ball, so when we after throwing the first ball, it will reach to the maximum height. Again, it will come back to the initial position. So total time of flight. So to reach to the total top, the time is u by g. Again, it will come back. So total time, so that is twice u by g. Okay, so when we throw the first ball, so it will take 2 seconds, again it will come back, again 2 seconds, but if we throw with more speed, then it will go upper side, so time should be, it may be more than that. Okay, so what should be the minimum time? So minimum time should be twice u by g. Minimum time should be twice u by g. Okay, so minimum time twice u by g. So what is minimum time? So upward flight 2 seconds, downward flight 2 seconds. So that is 4 seconds. Okay. So now you can see, so u should be greater than, so divide it by 2. So 2g. So it should be greater than 19.6. 19.6. So more than 19.6. So if it is at least 19.6, the first ball will reach to the ground, second ball is at maximum position, and third is about to start. If the speed is more than that, suppose speed is more than that, in that case the first ball is above the ground, second ball is in the higher air, and third ball may be above the ground. So in all the situation it should be. But if time is less than this, then the first ball is here, first ball is at the ground, second ball at the top, third may not be here. Okay, so this is the minimum required condition. Clear? Next example. A man drop a ball downside from the roof of the tower of height 400 meters. So consider tower of height 400. At the same time, okay, so consider first ball, a man dropped a ball. Dropped means initial velocity u 0. At the same time, another ball is thrown upside with velocity 50 meter per second. At the same time, another ball is thrown in upward direction with velocity 50 meter per second from the surface of tower. Then they will meet at which height from the surface? Okay, so both will reach, okay, or both will meet at one point. Okay, so this point, so you can say this point is meeting point. So this meeting point, it should be at which height? So assume this height is h1, from the ground. So naturally from the top another height it should be h2. It means distance traveled by upper ball h2, distance traveled by lower ball, so that is h1. Okay, so find out height h1. So now total height is given. Yes, total height is given. So we can use this. So h1 plus h2 is equal to 400. h1 plus h2 is equal to 400. Now h1, so that is distance traveled by ball in upward direction. So third case, so equation is ut. So both will take same time. So I can use ut minus 1 half gt square and h2. So that is first case. So h is equal to 1 half gt square because u is equal to 0. So total, so 1 half gt square, 1 half gt square cancel. So ut is equal to 400. U is given 50. T is equal to 400. So you can say t is equal to 8 seconds. So after 8 seconds, both the ball will meet. Okay. So what should be the height h? So after 8 seconds, h equation of h is ut minus 1 half gt square. So I can replace t is equal to 8. So 50 into 8 minus 1 by 2 g 10 t square 8 64. So 64 32. So 400 minus 320. So that is 80 meter. Okay. So answer is 80. Okay. So the the bottom ball will reach at the height of 20 meter. The upward will travel the distance of 320. Clear? So answer is 80. Clear? Next example. A very large number of balls are thrown vertically upwards in quick succession in such a way that next ball is thrown when the previous one is at the maximum height. So now assume suppose first, second, third, fourth. So when we throw the first ball, so when first ball will reach to the maximum height, second will be thrown. When second ball will reach to the maximum height, the third ball will be thrown like this. So we can throw n number of balls. If the maximum height is 5 meter, so now it is given maximum height h is equal to 5 meter. The number of ball thrown per minute. So in 1 minute, how many balls can we throw? How to solve? So only height is given and we want to find number of ball. So now calculate. So for one ball, what should be the time period? Okay, so for one ball, what should be the time period? So time of flight for the one ball. So that t is equal to u by g. So time t is equal to u by g. So initial velocity should be u. So initial velocity is given? No, initial velocity is not given. So calculate what is given height. Use the height. Then u is equal to under root 2gh. U is equal to under root 2gh. Okay. So now replace h. So 2 into 10 into 5. So 100. So that is u is equal to 10 and u is equal to 10. So 10 by 10. So time is 1 second. It means to reach the ball to the top, it will take 1 second. So in 1 minute, we can throw 60 balls. In 1 minute, we can throw 60 balls. Done. So here what is important? So first calculate time of flight for the one ball. Then you can calculate number of balls. Next, a particle is thrown vertically upward if its velocity at the half of maximum height. So particle is thrown in upward direction. So its velocity, suppose part at maximum height, the particle will reach to the maximum height. Suppose maximum height is h. So its velocity at the half of maximum height. So when h is equal to h by 2, v is equal to 10 meter per second, then maximum height attained by it. Find out maximum height h. So now when we throw the object upward, third case, so h is equal to u square by 2g. H is equal to u square by 2g, but u is not given. So now u is not given. So find out u. So use the condition. So velocity is given at height h by 2. So use the equation. V square is equal to u square minus 2g h by 2. So 2 cancel. So v square. So v is given. So that is 10. So I can say 10 square is equal to u square minus 2g h is equal to, again it is given, u square by 2g. So g cancel. So u square minus u square by 2. So I can say u square by 2. Okay, and here it is 100. So I can write u square is equal to 200. U square is equal to 200. So replace u square is equal to 200. So 200 divided by 2 into 10. So h is equal to 10. So height should be 10. Okay. So generally you will find such type of examples. So now stone is shot straight upward with speed 20 meter per second from a tower of 200 meter height. So now tower is given and height of the tower, so that is 200 meter, and stone is shot straight upward. Okay, so now stone is shot straight upward. So first stone will move in upward direction, then it will come the water with speed. So initial speed is given 20 meter per second from the tower of height 200 meter. The speed with which it strikes the ground. So find out speed at the ground. And so how to start? So first we want to find final velocity. So now we can consider the motion of the ball that is in downward direction. So we can consider this direction as positive direction. So value of g, so that is also positive. So final velocity v, okay, v square is equal to u square plus 2gh. V square is equal to u square plus 2gh. So downward direction g positive, h, so from this motion is starting. So in downward direction h is also positive. So h positive, g positive, and motion, that is positive. But what about u? So u is in upward direction. So upward direction, here we have to consider negative. Okay. So now replace the value u. So that is minus 20 whole square, 2 into 10 into height. Height is 200. Okay. So there is 400 plus 4000. So total 4400. So that is v square. So v is equal to, so if it is 3600, then 60. If it is 4900, then 70. So now intermediate. So between 60 and 70, what should be the answer? So answer should be 65. So 65 meter per second. Okay, so now focus on, so downward direction positive, so velocity in upward direction negative. Okay, if we consider upward direction positive, then here everything it should be negative. Okay, so this positive negative, so that is very important. Next example, a body freely falling from the rest has velocity v after it falls through the height h. So falls through the height h. Velocity is v. The distance it has to fall down from its velocity to become the double. It means initial velocity is v. Suppose our requirement is our velocity should be 2v. Then what should be the height of? So if initial height is h1, final height is h2. So final height h2 should be more than h1. So what should be the relation? So free fall u0. So equation is h v square is equal to 2gh. It means h is proportional to v square because 2g constant. So I can write h2 by h1 is equal to v2 by v1 whole square. Okay. So h2 is equal to h1. h1 is given. Okay. H into v2. v2 is twice v. v1. So that is v whole square. So that is 4h. So h2 is equal to 4h. Here. So here we have to use the relation. A body sliding on the smooth inclined plane. Body is sliding on the smooth inclined plane require 4 seconds to reach the bottom. Okay. So at the bottom, okay, suppose total distance traveled, that is s, and total time, so that is 4 seconds. From the rest, so initial velocity 0. How much time does it take to cover 1/4 distance starting from the rest at the top? Okay. So when we start the motion from the same point, but how much time it will take to cover 1/4 distance? So find out time t. So cover 1/4. So now motion along the straight line. So equation between s and t. So in initial u is equal to 0. So s is equal to 1/2 a t square. Here I am not using g because inclined plane acceleration is different, not g. Okay, it may be g sin theta or g cos theta. So depends on theta. So s is proportional to t square. So t is proportional to root s. So I can write t2 by t1 is equal to under root s2 by s1. So t2 is equal to t1 total time. Total time is 4. s2, so distance traveled in new situation, so that is s by 4, and total distance s1 s, that is 4 by 2. So t2 is equal to 2 seconds. So you can see, so for to cover 1/4 distance it requires 2 seconds, and to cover full distance it requires 4 seconds. It means initially speed is slow, finally speed is very large because motion is accelerated motion. So similar situation in the water park. When you start the ride, initial speed is slow. Okay, so it means you are moving slowly, but at the end speed is very large. Okay, so whenever you see the end, you can reach the end very quickly. Okay, so at that time is very less. Okay, so you will drop in the water, but at that time your eyes is closed and you feel the thrill. Okay, so you can compare the same example. Okay, so in the next lecture we will solve more examples, and also we will solve example, if time permit, based on differentiation and integration. Thank you very much.